Alright, you guys, tonight's notes are on the correlation coefficient, or it's R if you find it in your calculator. That's how you know. We already talked about today in class how to find it using your calculator, so you should have those notes from class. What I want to talk about is what does it mean. Okay, the correlation coefficient, that's how closely related two variables are, all right? How closely related they are. In fact, the word correlation is co-related, right? I might have spelled that wrong. I'm so sorry if I did. Two variables are related. Okay, and actually I'm going to keep talking and I'm going to check on how to spell if it's L-E-Y or E-L-Y, but while I keep talking I want you to write the rest of this stuff down. Correlation, how closely two variables are related. Now as you can see, that paper that I gave you to take home, if you can cut those out and paste them in your notes so that you don't have to draw all these different graphs, right? You can just use the pictures that I gave you and paste them in there, cut them out, paste them in there. If you want to do it all at once, that's up to you. Just make it look nice so there's no paper hanging out the edges of your notes. I'm actually going to pause this while you do that, and I will be right back with you. Alright, you guys, I'm back. I looked it up. I was correct. I don't know if you guys ever know the feeling when you just look at something, you're not sure it's spelled correctly, but closely two variables are related. So the closer all of the dots are to a straight line, the higher the correlation coefficient. But the correlation coefficient can only be between -1 and +1. And what that 1 means is 1 to 1. Every time something happens to the x variable, the same thing happens to the y variable. That's a 1 to 1. Now, here's what's really confusing. -1 does not mean they are not correlated. -1 means that they are perfectly correlated, but the relationship is negative, like a negative linear relationship. A +1 means that two things are perfectly correlated positively. So what that means is that there's absolutely no correlation if your correlation coefficient is 0. So you can see that right in the middle here, right? 0 correlation means that one thing does not affect the other at all. And I'll use my academic language. One variable does not affect the other one at all. Okay, now there's a difference between one thing affecting another thing and one thing causing another thing. So remember, just because if one thing changes, the other thing changes also, does not mean that it's causing it to change. And think back to what we did in class. There was that strawberry jam sold in New York. Every time that went up, strawberry jam or CDs in Florida sales went up. So if one thing changed, the other thing changed. However, it wasn't causing it. There was probably something else that was causing the same thing. And that's where your detective work comes in when you're a researcher. You've got to think, what could be making both of those things change at the same time? And if you're always thinking that way, it's going to help you in the real world so that you're not listening to somebody just say, oh, you need to do this because here is the research. You can actually look at their research and say, well, maybe it's not right. I don't think you're looking at this research correctly. So let's take a look at some of these numbers that we have. A perfect positive correlation is 1, is positive 1. That's the first one you see right here. Okay, a perfect positive correlation. A high positive correlation, now that came out to 0.8, which was close to 1. 0.8 was close to 1, but not quite perfect, right? It's some real world data. Like, there's always going to be outliers. But it's higher than the next one, which is 0.3. And the other way you can think about that is that if 0 means there's no correlation, right? If 0 means there's no correlation, 0.3 is closer to 0 than it is to 1. So that's low. 0.8 is closer to 1 than it is to 0. So that's a higher positive correlation. And we know it's positive because if you look, if you drew a line of best fit, you would definitely draw it like positive and not negative, right? Leaning towards the positive side, going up. Every time one variable is going up, every time x goes up, the y value also goes up. So skip down to the bottom, and you have low negative correlation, which was negative 0.3. Okay, negative 0.3 is closer to 0 than it is to negative 1. Like, if you think about a number line, and here's positive 1, and here's negative 1, and here's 0, and here's negative half, negative 0.5, negative, let's see, 1, 2, 3, 4, 1, 2, 3, 4. Negative 0.3 is going to be here, closer to no correlation than it is to negative 1, which is a perfect negative correlation, okay? So that's a low negative correlation. Now look at the next one. It says negative 0.8. Well, that's going to be here, which is closer to perfect negative correlation than it is to 0, which is no correlation, okay? Some other words we use are strong. Negative 0.8 would be strong, a strong correlation, and negative 0.3 would be a weak correlation. So we can use those words. Oh, I'm going to throw them up in academic vocabulary. We have strong and weak, right? Strong and weak is a good way to describe these. And then, of course, the last one, negative 1, is a perfect negative correlation, exactly a 1-to-1, right? I'm going to add, might as well put a star on all of them, right? So what we're going to do, let's see, can only be from negative 1 to 1, a 0 correlation. Okay, I just want to once again reiterate causation, and we'll talk a little bit about this more in class. Just because the same thing is happening to both the x and the y does not mean one is causing the other. And in fact, let's write this down. Just because the same thing is happening does not mean one thing is causing it, the other thing to change. Does not mean one variable is causing, ran out of room, causing the other to change. Okay? Just because one is changing doesn't mean that the other one is changing. I'm going to check the time here really quick and see if we can just do the practice problems on here. Yep, I have about just a little bit of time to go over one problem. It's not going to take long. in the same video, so you don't have to switch videos. And I think I have it all queued up here. It is, oh yeah, ice cream sales versus temperature. Okay, so it looks like temperature, if we were to define our variables, temperature, X is the temperature in degrees Celsius, Y is the amount of ice cream sales. It looks like they're using dollars. And it looks like the sales go up when the temperature goes up, and that makes sense because people want ice cream as it gets hotter. So if we arrow down here on this website, it gives us the scatter plot, and I can tell even before I find my correlation coefficient that it's going to be pretty close to a positive 1. If I were to draw a straight line through those points, they would all be pretty closely pretty close to the line, right? I can tell already that it's going to be a strong positive correlation. But what you can do is you put it in your calculator like I showed you, and I did. I put the data, all of this data up here into my calculator. I made my own scatter plot, and then I told the calculator to find my correlation coefficient. So that was, let's see if I have room to do up here. My equation from the calculator ended up being y equals 30x minus 159.47, which means that for every degree Celsius, I have $30 more worth of ice cream sold. That's what my slope means. And then if I sell $0 worth, or if it's 0 degrees, the y-intercept is if it is 0 degrees out, I lose $159. That's because it's negative 159. So if it's 0 degrees, I'm actually losing money. I'm not making any money in my ice cream shop. But it also gives me my correlation coefficient. My R was 0.9575. So, as you can see, a very, very, very strong positive correlation because it's very, very close to positive 1. If you look at the number line down there, I'm going to go back to the number line, 0.9575 is going to be almost at 0.1, right? Very, very strong relationship. So please make sure you have all of this written down. We'll do a summary in class. And please make sure you're coming to see me if you have any questions on this, because this is kind of a, can be a confusing topic, but we'll keep talking about it in class. And, well, I was going to say something, but I'm not going to because I'm not positive. So I was going to say, well, next time I see you, we'll have a quiz, but I'm not positive about that. So remind me in class to talk about that, and I hope you have a good night.